Let's jump right into this explainer. We've got a really fascinating and honestly kind of terrifying topic to break down today. We're looking at a brand new, highly stealthy Python-based threat that's quietly targeting Windows systems right under our noses. It goes by the name DeepDoor, and this thing, it represents a massive leap in how attackers are bypassing modern security. We're gonna map exactly how it works, how it hides, and why it's literally keeping cybersecurity researchers awake at night. Just to set the stakes here, once this malware gets inside a system, it can steal, well, pretty much everything. Browser passwords, your enterprise cloud credentials, your SSH keys. It can even hijack your microphone and webcam to secretly record ambient audio and video. I mean, it is built for total surveillance and long-term control. So, Section 1, the invisible threat. How exactly does something this powerful just slip by our defenses?
The most chilling part of DeepDoor isn't just what it steals. It's the fact that it operates without obvious malware downloads or those easily flagged dedicated hacker servers. It functions as a RAT, a remote access Trojan. So what does that actually mean? It basically hands attackers complete direct control over an infected machine. They can silently move the mouse, open files, or record screens without ever setting off alarms. It's like they're sitting right in your desk chair.
Researchers over at SecureNext describe DeepDoor not just as a one-off virus, but as a flexible framework. It doesn't rely on clunky, traditional executable files that, your antivirus is already trained to catch. Instead, it uses interpreted scripting, Python specifically, and native Windows functionality. Basically, it weaponizes the exact tools your operating system already uses every single day. Right, so on to Section 2, Anatomy of the Infection. Let's walk through how a framework like this actually gets onto a machine. The infection chain here is incredibly strategic. Step 1, it almost always starts with a phishing delivery, like a deceptive email attachment. Step 2, the user gets tricked into executing a batch script called install-obf.pat. Step 3, that script immediately goes to work disabling your Windows security controls. And finally, Step 4, it extracts a hidden Python payload named svc.py. So the really crucial takeaway here is that the core implant is already embedded directly inside that initial dropper script. It doesn't have to reach out to the internet to download some suspicious payload. That limits network traffic, severely reduces forensic evidence, and just makes the whole thing incredibly hard to detect. Now, Section 3, maintaining total control. Because once DeepDoor is in, its #1 priority is making sure you can't easily kick it out. The malware uses an overwhelming array of persistence mechanisms to ensure it survives reboots, logouts, and even attempts by an IT admin to clean it up. It creates multiple redundant backdoors all at once. We're talking Windows startup scripts, registry run keys, scheduled tasks, even WMI event subscriptions. But, okay, here is the absolute craziest part, the watchdog recovery. If a security tool or an administrator actually manages to find and delete one of these persistence methods, the malware's watchdog function immediately notices and just automatically recreates it. It actively fights back to maintain its access. Unbelievable, right? So how does it communicate back to the attackers? Well, traditional malware usually relies on dedicated hacker command and control, or C2 servers with hard-coded IP addresses. Security teams can just block those IPs, right? Easy enough? But DeepDoor takes a totally different approach. It abuses a Rust-based public tunnel called boar.pub. And because this is a legitimate public service, the malicious traffic blends in perfectly with normal, everyday internet traffic. The attackers don't have to spin up visible servers, and there are almost zero obvious red flags for network defenders to spot. It's basically the cybersecurity equivalent of wearing a high-vis vest and carrying a clipboard to sneak into a secure building. Nobody even questions it. Section 4, the ultimate payload. Let's look at what they actually do with all that stealthy access. Take a second and think about the terrifying implications here. What actually happens if they get your SSH keys and cloud credentials? We aren't just talking about someone hacking a local PC to steal some personal photos. If a single developer at a company gets infected and DeepDoor steals their SSH keys, that malware just gained the keys to the entire enterprise cloud infrastructure. It's game over. The huge array of targets really proves that DeepDoor is hardcore, infrastructure-focused espionage tooling. It harvests from Google Chrome, Firefox, and the Windows Credential Manager. It specifically hunts down AWS, Azure, and Google Cloud Platform keys. And on top of that, you've got key logging, clipboard monitoring, and the ability to silently turn on your webcam and record ambient audio. I mean, make no mistake, this is not consumer malware.
This is a weapon designed to compromise entire organizations from a single beachhead.
Moving on to Section 5, the art of evasion. Because pulling all of this off silently requires defeating some serious modern cybersecurity defenses.
The sheer volume of techniques DeepDoor uses to blind security tools is just staggering. It leverages sandbox and virtual machine detection to actively avoid analysis. It uses AMSI patching and ETW tampering to completely silence Windows telemetry. It literally interferes with Microsoft Defender and goes in and clears its own event logs. This level of sophistication proves the attackers have a deep, intricate understanding of Windows internals. They know exactly how enterprise detection systems work, and they know exactly how to turn them off. Which brings us to Section 6, the new era of malware. DeepDoor isn't just an isolated threat, it's a symptom of a much larger shift. Modern attackers are rapidly moving away from noisy binaries towards stealthy, script-driven frameworks. In the industry, we call this living off the land. When malware uses native operating system components and interpreted languages like Python to do its dirty work, traditional signature-based detection completely fails. Why? Because your computer thinks it's just running a normal, permitted script. And that brings us to the core reason why this explainer really matters. One infected endpoint can become an entry point into an entire organization. Because our modern workflows rely so heavily on browser-stored passwords and cloud authentication, the old idea of a secure network perimeter, that's completely dead. A single compromised laptop sitting in a coffee shop can bring down a multinational company if the right credentials are stolen. And honestly, it takes shockingly little infrastructure to pull this off today. It really boils down to just three things: a script, a phishing email, and a public tunnel. That's it. No massive, expensive hacker servers required. Just those three things. Which leaves us with this final thought to end today's explainer. If the most dangerous malware today looks completely normal, blending in with standard Python scripts and legitimate tunneling services, how will you know when you're already infected? It's a really daunting question. But it's exactly why understanding these frameworks is absolutely crucial for the future of our digital defense. Thanks so much for walking through this deep dive with me today. Keep asking questions, stay secure, and we'll see you next time.